Alright, in this video, we're going to be doing some practice with grams, atoms, molecules, and moles in a certain sample. Alright, we're just going to be converting from one to another. And let's go and start off with this one. Okay, the first question is telling us, determine the molecular mass of acetylsalicylic acid, which is also known as aspirin, the common household pharmaceutical that you might be taking if you get sick. So the formula for aspirin is C9H8O4. Alright? So the molecular mass, what is a molecular mass? So molecular mass is basically the mass of something, the mass of a certain compound when it's present in 1 mole. Alright? The presence of 1 mole of this stuff, how much is that going to weigh? That's basically what the question is asking us. Okay? So in order to do that, we need to look at the periodic table, which I have over here to the right. And the first thing you need to do is write down what elements you have. So we have carbon, hydrogen, and oxygen, right? So go ahead and write carbon. And let's go ahead and let's go write carbon, hydrogen, and oxygen, right? So let's look at the periodic table. So if you see right here, if I were you, I would just get out your periodic table, because this periodic table is kind of small and it might be hard to see the 12.01. Maybe that's better. But get out your periodic table from the back of your workbook just so you can follow along better. But the mass of 1 mole of carbon is actually 12.01, as indicated by the mass number right here. Alright? So let's go over here and put carbon equals 12.01. And let's go ahead and save the rest of the calculations for right now. Alright, so if we look at hydrogen, hydrogen is 1.008. And oxygen is about 16. Alright? So 16.00 grams per mole, right? Let me write my units. Okay, so now that we have the mass per 1 mole of each of these atoms, we have to determine how many moles we actually have within this compound, or this molecule. So you see here we have 9 carbon atoms, as indicated by the subscript right here, right? So we have 9 carbon moles actually in 1 mole of this entire thing, right? So what we're going to do is we're going to multiply this number by 9 moles, alright? 9 moles of oxygen. Okay, so let's go and do that calculation. Let me get out my calculator here. So 9 times 12.01 gives us 108.09. And hopefully you guys are raising the red flag like, hey, why isn't he using correct significant figures? And the reason for that is you should really only round to your significant figures when you're finished with your calculations. Alright, it just helps with not throwing your answer off. So don't round until you're finished with your calculations, okay? Now we look at hydrogen, and we said there's 8 moles of hydrogen within this compound, right? As indicated by that subscript. So we do the same thing over here, times 8 moles equals this. So 1.008 times 8 moles is equal to 8.064 grams of hydrogen. Let me label this as grams of carbon. Alright, so oxygen over here, so we see that oxygen is present, has 4 moles within this 1 mole of molecules. So we're going to write times 4 moles, and that's going to give us 64.00 grams of oxygen. Alright, so now to determine the molecular mass, we have to add up all of these together. Alright, so let's see, 108.09 plus 8.064 plus 64 will give us 180.154. Alright, now significant figures, we should really go with 4, just because that's what it gives us in the periodic table. But as far as this question, they didn't really give us a number to base our significant figures off of. So I think we could just go ahead and be safe and just label this as 180.2 grams per mole of aspirin, which is C9H8O4. Right? So that's the molecular mass of aspirin. Um, let's move on to the next one here. So how many grams of sodium are there in a 83.76 sample of sodium chlorate? Okay, so now the first thing you need to do is obviously tell or ask yourself, what is sodium chlorate? What's the formula for that? Well, just a quick refresher. Sodium located in the +1 column, while chlorate is located in the -1 column. It takes one of each to cancel each other out. And remember that chlorate is ClO3 minus, so this should be NaClO3. That's the formula of sodium chlorate. Alright, now make sure for the next exam that you really get down your naming and creating formulas based on the name. Alright, because if Dr. Becker or Dr. Sulfate asks you a question about this on the exam and you have no idea how to even write the compound, then how in the world are you supposed to get the correct answer, right? So make sure you master that, alright? You're going to be using it in Chem 1 and Chem 2 if you have to take Chemistry 2, okay? Naming never goes away, alright? So NaClO3, and we're going to go ahead and label, we're going to go ahead and just write out what they give us. So they give us 83.76 sample of sodium chlorate, right? So 83.76 gram sample of sodium chlorate. Okay, now the question wants us to find how many grams of sodium are there. Okay, well, we have to compare apples to apples, right? So we can't just say, okay, sodium chlorate, grams of sodium chlorate, and somehow just all of a sudden jump into grams of sodium, right? You can't do that. First, you have to calculate into moles, right? Going into moles is pretty much the first step you'll do for all of Module 3, right? And possibly even most of the semester. Okay, so first calculate into moles. So how do you do that? You have to do the same process you did up here and calculate the molecular mass of sodium chlorate. Alright? So let's go ahead and do that down here. So we have one sodium, so 22.99 grams per mole, plus chlorine, which is 35.45 grams per mole, plus 3 oxygens, so 16.00 grams per mole, times 3. Alright? Now, while I do this calculation, you as students should be practicing so much to the point where you actually start memorizing the molecular masses of, or the atomic masses of some of the more common elements, such as oxygen or nitrogen or carbon or sulfur, sodium, potassium, hydrogen especially. Some of these you see over and over and over again, and you should do enough practice to the point where you start memorizing them subconsciously. All right. But anyways, 22.99 plus 35.45 plus 16 times 3 is equal to 106.44. Right? Grams per mole. So we're going to go ahead and put this on the bottom here because we want to cancel out grams of sodium chlorate. Alright? So we're going to put 106.44 grams of NaClO3 for every 1 mole of NaClO3. Right? So far, grams cancel out grams. Right? You can't cancel apples with oranges. Right now, we're comparing apples to apples, and they're able to cancel out. Right? So before we even get to grams of sodium, obviously we have to get into moles of sodium, right? So we're going to use what's called the mole ratio. So the mole ratio is basically within a mole of one thing, a mole of one larger thing, which is our sodium chlorate, how many moles of a smaller thing are there? Right? So to calculate that, you just look at the subscript of sodium, and you see here that sodium has a subscript, an imaginary subscript of 1, right? So what we're going to do is we're going to say, okay, so in 1 mole of NaClO3, we have 1 mole of sodium. Alright? And I got 1 mole of sodium just based on the subscript of sodium right here. in the sodium chlorate calculation. So if I were doing this for oxygen, I would say 3 moles of oxygen per every 1 mole of sodium chlorate, just based on the subscript here. Alright? So now that I'm in moles of sodium, I can go ahead and calculate grams of sodium. Alright, so maybe I should use a molecular mass, right? Atomic mass. So 1 mole of sodium is going to be equal to 22.99 grams of sodium. Right? Sodium cancels out, moles of sodium chlorate cancel out, and we're left with grams of sodium right here. Right? Now the thing I always tell my students is your units don't lie. If you carry your units all the way through, you write out all your units, you cancel things out, and you end up with the units that the question is asking you for, chances are you have the question correct. And unless you make a silly mistake on plugging in these values into your calculator, you should have the question correct. Alright? If your units aren't canceling out, then obviously you did something wrong. Okay, so make sure you go back and check what you did and try to cancel out your units. Okay? Okay, so 83.76 divided by 106.44 times 22.99 gives us 18.09 grams of sodium in sodium chlorate. Alright? And our significant figures are correct because the question gave us 4 and we're providing 4 on our answer, so we're good there, right? Now let's move on to the next one here. Calculate the amount of potassium atoms within a 101.01 gram sample of potassium sulfate. Alright? So the first thing we should do is write out what they gave us. So 101.01 grams of. Okay, so now what is potassium sulfate? Right? Quick refresher again. Potassium is in the +1 column, right? It's right here. And sulfate is inside the -2 column. So sulfate, remember, since it's inside this box here in the rule of 7, it's going to have 4 reference oxygens. So when we say sulfate, we're talking about SO4 2 minus, right? So it takes 2 potassium to cancel out 1 sulfate, so K2SO4, right? And these namings, these naming compounds should just come automatic to you, alright? On the exam, you don't have time to wonder what is the formula for a certain chemical name, alright? You don't want to waste time doing that. So make sure you master these before the exam, okay? So now, we're in grams of potassium sulfate right now, right? Now the first step in pretty much any mole calculation is obviously to calculate moles. Okay, so how are we going to do that? Just like we've been doing up here, molecular mass, right? The molecular mass allows us to go from grams to moles. Okay, so we're going to add potassium, which is 39.1 grams per mole. And remember, there's 2 moles here, so 2 moles plus 1 mole of sulfur. Sulfur is 32.06 grams per mole. Times 1 mole plus 4. Okay, so let me write the mass. So 16.00 grams of oxygen per mole of oxygen, and we have 4 moles of oxygen here. And remember, I'm getting all these masses from the periodic table. Potassium right here is 39.1. It's kind of hard to see right there. Let me go ahead and erase all this. Oxygen is 16. Sulfur is 32.06. Alright? Just in case you're wondering where is he getting all those values from. Okay? So let's go ahead and calculate this. So remember, realize that moles cancel out all the way through here. So our end units are going to be grams. Okay, so 39.1 plus 2, no, not plus 2, 39.1 times 2 plus 16 times 4 plus 32.06. Alright, so 174.26 grams of K2SO4 for every 1 mole of K2SO4. Okay. Now, let's go ahead and plug that in up here. So we should divide by grams of K2SO4, right? So that way we can cancel out. So 174.26 grams K2SO4 for every 1 mole of K2SO4. Okay? So now, the next step should be what? Ask yourself, what should we do next? Okay? Grams of potassium sulfate cancel out, right? Apples to apples. So we should do something similar to what we did up here, right? We should do the mole ratio again to go from moles of the entire molecule to just moles of one atom, right? So we're going to say that in 1 mole of K2SO4, how many moles are there of potassium? We'll look and see look at the coefficient, or actually the subscript of potassium. We say that potassium has a subscript of 2, therefore we should put 2 over here. So there's 2 moles of potassium in every 1 mole of this entire potassium sulfate, right? So the next step, you should be asking yourself, how do we go from moles to atoms, right? Because the question is asking us potassium atoms within potassium sulfate, right? Now, you should already know this number, but this number is called Avogadro's number, right? And this is atoms or molecules per mole of whatever you're talking about, okay? In this case, we're talking about atoms of potassium per mole of potassium, right? I'm not going to really explain what Avogadro's number is. That's what you have a lecture for, right? So let me go and plug this into the calculator. So we have 101.01 times, divided by 174.26 times 2 times 6.022 times 10 to the 23rd. Alright? And my calculator here is giving me 6.98 13 times 10 to the 23rd atoms of potassium. Alright? And notice here that even though this number looks weird, the question gave us 5 significant figures, so I made sure that I included 5 significant figures in my answer. Alright? So sig figs still do matter, so make sure you include them, right? They don't just go away after the first exam. So yeah, that's how many atoms there are within the sample of potassium sulfate. Okay? So this last one here, calculate the amount of protons in 76.1 grams of carbon. Alright? So there's a question similar to this on your homework. It's actually number 3, I think. But anyways, hopefully you pay attention to this. Calculate the amount of protons in this amount of carbon. Okay, so let's go ahead and write down what we're given. Right? So just like we've been doing this entire video, we should calculate moles first, right? How many moles are within this sample? Right? So we see carbon has a mass of 12.01. So we're going to plug in it over here. So 12.01 grams of carbon for every 1 mole of carbon, right? Now, before we go any further, let's sort of conceptualize what we're looking for. So we're looking for the amount of protons, right? Well, how in the world do we calculate that? I've been realizing that a lot of students actually get really confused about this, but a lot of students assume that there's only 6 protons within an entire mole of carbon, which is not true, because remember, each atom of carbon has 6 protons. However, an entire mole of carbon weighs this much amount of grams. Alright? So it's kind of confusing, but this 6 right here, the atomic number, pertains to only 1 atom, while the mass right here pertains to an entire mole of that element. Alright? So before we get protons, obviously we should get atoms, right? And before we get atoms, hopefully you can sort of plan out what we're going to do here, but we should be using Avogadro's number somehow, right? Okay, so maybe we should use it here. So we're going to say 1 mole of carbon is equal to 6.022 times 10 to the 23rd atoms of carbon. Alright? So now that moles of carbon cancel out, we're in atoms of carbon, so we're one step closer. Now we're going to say that in one atom of carbon, there are 6 protons, right? Where am I getting the 6? Right here from the atomic number, alright? Dr. Beckford and Dr. Sulfate spent a lot of time covering this at the beginning of the semester, right? The atomic number, mass number, isotopes. This is where it comes into play, alright? So atoms of carbon cancel out, and we're left with protons, okay? And you can't really say protons of carbon because protons compose carbon, right? Carbons don't make up a proton. So we're just going to leave that as protons, not as protons of carbon. Okay? So 76.1 divided by 12.01 times 6.022 times 10 to the 23rd times 6. And my calculator is giving me, let's see, we're supposed to have 3 significant figures, so let me round this up to 2.29 times 10 to the 25th protons. That's a whole lot of protons, right? That's, how many zeros is that? 23? Oh well. But anyways, I think, yeah, that's the last question I had here. Hopefully you found that helpful, and contact your peer leader if you have any other questions. All right, thanks for watching.